Okay. So is the screen visible?
Yes, sir.
Okay. So yesterday we were discussing about applets. I gave you an introduction about console-based application and GUI-based application. I told you the difference also between console-based applications and GUI-based applications. So from now onwards, we are going to see graphical user interface-based applications. So as part of that, first we'll see a simple applets. Then we'll see AWT also, abstract window toolkit. Right? So let us begin with applets first. So as part of this applets, we are going to see how to create a window. For example, what is a window means? See, a notepad is a window. Now, you can consider this notepad as a window, and it has some title bar at the top, where whatever file name you have given to this current file, that name will appear here because we didn't save this notepad window with some name. It will be displaying untitled notepad. But once we start typing something here and then save it with some name, this window will be displaying that particular name of that file at the top, right? Just like this one. For example, this program, this notepad window is displaying what? Simple applet. And it is open in a notepad window. And this from the top left corner to the right corner, we call this as the title bar. So you will have these options at the top right corner to minimize it, maximize it, and close the window. Right? And at the bottom also, you'll have some status bar kind of thing where you will be able to see the line number where the current cursor is currently available. So the cursor is located at the beginning of the file here. So it will display line number 1 and column number 1. So it is your notepad window is just like a matrix which contains some rows and columns, right? In each column, you can type a single text. In the same way, even your applet window also contains some rows and columns. It is nothing but a matrix of pixels. Right? So as such, we'll have some coordinate values. Say in our program, we are saying 20, 20 means 20th line, 20th column. So that is the meaning of that 20, 20. So that is what here in case of notepad it is displaying line number 11 and column number 41. And what is the width occupied by this window on your screen? 100% occupied, right? So and encoding scheme that is being used here, that is displayed here. So this part at the bottom of the window is called as a status bar. So in the same way, using a Java applet programs, we can create some window and display some text or something, some object or some uh, any any figure or a diagram or something we can display applet, right? But nowadays, most of the modern applications they are not using these applets anymore because they have become obsolete. They have become outdated. So now these are not being used. Many advanced concepts came into existence, so people are not using these applets. But anyhow, you should know about this applet. It used to exist once, and it was very important in when the Java was initially introduced. But later we'll switch fast to another concept called abstract window toolkit. That will be creating a little bit more sophisticated window when compared with an applet window. There we'll be seeing some controls also. Some controls in the sense some text fields, radio buttons, check boxes, all these things we can create and lay them on the abstract window, toolkit window, AWT window, and even you can interact with the database also with using such application. Right? Before going to that extent, first let us see what is an applet, and then we'll switch to that AWT concept. Okay? So already I introduced about what is an applet. Applet is a small application program. It is run over internet. It will work under client server environment concept. It will be transferred from the server to the local system of a client, get installed, and then it will start running on your client machine. But when this applet starts running on the client machine, it will have a limited access to the resources of the computer. That is the client's computer. Okay, limited access means limited access to resources means only those resources which are useful for this applet to run. So other than that, it is not going to interfere with any of the data stored on your computer, or it will not do any manipulations. So that is nothing but it is going to create a risk for you. It is going to attack your computer privacy and do all those kind of things, right? So that is not permitted for an applet. So in that sense, we say it has a limited access to the resources, so that it can produce a graphical user interface and run complex computations. So these applets are different from console-based applications. Today also we have seen this simple program, right? Uh, this is a simple example applet program using which we can create applet. So if you look at the first two lines of this program, we are importing two different packages. One is AWT package and the second one is applet package. We are completely importing the entire package by writing dot star at the end. Right? So here you can see we are creating an applet. So how we are creating an applet means earlier we have used some concept, the same concept when we were creating multi-threaded Java programs. So how do we create a thread? In two ways we created threads. One way is by creating a class which extends thread class, and the second way is by creating a class which implements runnable interface. Right? There are two ways there. But coming to this applet, there is only one way in which you can create an applet, but simply by creating a class which extends applet class. So that means what? If you want to create an applet of your own, you need to define a class and make that class a subclass for a predefined class called applet class. Where is this applet class located? In the applet package. Okay? So that is the reason why we imported this applet package. And this class must contain a method called paint method. It may contain many other methods which are called as life cycle methods. We will see later what are those life cycle methods. Along with this paint method, there are some four other methods which we call them together with this paint as life cycle methods. Okay. So because this is a simple applet, we are not using all those other four methods. We are only using the paint method because this is this method is a main method. It is just like a main method in other console-based application programs that we were writing till now. So every class, every program, every Java file has a main method. If it is having one class or more than one class, no matter whatever, how many classes are there, uh, one class will be definitely having the main method, and that is the starting point of execution of that program. So similarly for an applet also, we'll have some life cycle methods, init method, start method, paint method, stop method, and destroy method. So we are not discussing about all the five methods here, but we are simply seeing only one method here. So what is this paint method going to do is, once an applet window is created, paint method, as its name indicates, it is used to paint your applet with whatever you want. Whether you want to display some text message on the applet window, or you want to draw an object of different shapes, an oval shape or a circle shape or a rectangular shape. So whatever object you want to draw on the applet, you can make the drawing. Uh, So using this paint method. So each time you want to make some presentation on your applet window, either by displaying some text message or by displaying an object, this paint method will be automatically called. Okay. And this paint method has a parameter which is an object of another predefined class called graphics class. This graphics class is available in AWT package. So that's why we are importing this AWT package even. And this graphics class contains a method called drawString method. So just like drawString method, to draw a rectangle, you have a drawRect method. So in that way, for different objects, you have different methods. We are not going to see all those methods. We'll simply see one simple applet because these are outdated concepts. Right? So I'll just give you an introduction to applet concept and how to run this applet program, how to compile and run this applet program, how to use all the life cycle methods, and how to use the paint method to create a simple text message and a moving text message on an applet window. And then we'll quickly switch to AWT concepts, which is far more important than this applet. So what you can do with AWT, you can also do with applet, but AWT are more flexible than applet. And that's the reason why we'll focus more on AWT concept. Okay.
సార్ హలో
So,
సార్
hello.
ఒక్క చిన్న క్వశ్చన్ సార్ హలో హలో
Yeah, cheppu.
సార్ ఇప్పుడు మనము
Yeah,
యాప్లెట్
cheppu.
యాప్లెట్ కాన్సెప్ట్ వాడుతున్నాం కదా సార్ యాప్లెట్ లో మళ్ళీ ఏడబ్ల్యూటీ కూడా యూజ్ చేస్తున్నాం కదా అంటే రెండు ఇంటర్నల్ గా లింకే కదా సార్ సపరేట్ కాన్సెప్ట్ అవ్వవు కదా
రెండు లింక్ అయి ఉంటాయి బట్ we can write a program without an applet also. Only pure AWT తో రాసుకోవచ్చు. Applet మాత్రం applet is dependent on AWT.
ఓకే సార్
AWT is dependent on applet. Applet is dependent on AWT. Okay?
ఓకే సార్
So that's why we'll use mostly AWT than applet. So look, coming to the explanation for this import statements, the first import statement will import the AWT classes which are located in the AWT package. So how does applet interact with the user means they'll interact with through this AWT only, not through the console based IO. So your applet is just like a layer which is laid on the photo frame. So you know a photo, you can make a physical copy of a photograph and make it as a frame and put it on the wall. Right? So what you will do, you will have a physical hard copy of a photograph. You'll stick it on a cardboard kind of a thing, and then design a frame surrounding it, and you will hang it on the wall. Right? You can put it on the table. So your applet is just like a photograph, and AWT is like the entire photo frame along with the photograph. So if you want to lay this applet on your window, we require this AWT support. So if you have this abstract window toolkit, then the applet will be laid onto this AWT window. So instead of laying the applet onto the AWT window directly, we can use other components and lay them on the AWT window later. So we'll not focus much on applets. Okay. I hope you understood the difference between applet and AWT.
ఎస్ సార్
Photograph, right? Okay. So applets, how do they interact with the user means they either directly or indirectly through the AWT window only. And we are not going to use the console based command prompt. Okay. So what does AWT contains means it contains support for a window based graphical user interface. So whatever window that is provided by the AWT package and its classes defined in that package, we call that as a graphical user interface. Okay. And because it is a window based, we call it as a window based graphical user interface. The second import statement, it is importing the applet package which contains the applet class as I told you earlier. So every applet that you create must be a subclass of applet. This is also already discussed. So how to create an applet class means we need to create a class and make it a subclass for the predefined class called applet, which is defined in the applet package. Rest everything is explained already, right? The class name is simple applet and it is defined as a public because it will be accessed by the code that is outside the program. Fine. And the paint method also, I also discussed it regarding this one. So first, now let me show you how to compile this program and run this program. So let me create another folder here called applet. Let me move into that. Oh, an applet was created. Now I'm going to save this program as simple applet. So now we have saved the program in this applet folder. Let us compile and run it first. But before going into the compilation, let me tell you about something additional which is required here. See, when you write an applet program, to run an applet program, we don't require the Java command. We only compile it first. We will not run it directly, just like we do it for earlier programs, console-based programs. So the approach for running applet program is different. So what you have to do is in your Java program, after the package statements and before you start defining the class, put it in comments and write this code. It is HTML code kind of a thing. You will have a HTML tag called applet tag. For that, you will have an attribute called code attribute is equal to whatever class name you are giving here for your applet, simple applet. The same thing you have to give it here. Code is equal to simple applet. And because applet is going to display this output on a separate window, which is provided by the AWT, right? So we need to specify with how much width and height you want to display that value. So I'm giving it as to specify that you have attributes called width attribute and height attribute. So I'm giving width is equal to 200, which means 200 pixels of width, and height is 60, which means 60 pixels of height. Right. So this thing is mandatory in every applet program. You need to definitely write this and then define your applet class. What is this class doing is it is displaying a message, a simple applet at coordinates 20, 20. So to run this program, what you need to do is directly run it as you do with normal Java programs. Simple applet dot Java. So once this is done, you will get the dot class file in the folder. Now to run this applet, you have a separate tool. Instead of using the Java tool to run the Java program, we have to use another tool called Applet Viewer, AppletViewer, Applet Viewer. Okay, and then give a space, give the file name simple applet. Here you need to also give the extension .java, right? Simple applet.java. When you are running a normal Java program, console-based program, you'll use instead of applet viewer, you'll use Java here. You'll not use the .java. Right? But coming to this applet viewer, you have to specify .java. Right? Now strike the enter key. Okay. So now you can see the applet window created with that height and width. You can maximize it. If you maximize it, then it will occupy the entire computer screen. And you can minimize it. So you minimize with whatever pixel size you have specified. You can even change its, alter its width and height by dragging it like this. Okay. So this applet window is created. You can see the message a simple applet. So this message is displayed with the help of that drawstring method. We are calling a drawstring method, right? So that is drawing this message here. Where is it drawing means it is drawing starting from coordinate 20 comma 20. If I change this say to, let me say 500. Actually, earlier this used to work, giving a specifying a height and width. If you want to compile it again, you have to close the existing applet window. Then only you will get the command prompt here. Now the width has changed, even the height has changed. Right? So how much width we have given? 500 and 100. Height is 100. So height is increased to some extent, and even width is also increased to some extent. In that way, you can alter the width and height. And even if you want to change say this to 200 and 200 like this, you can change. Close it. Again, compile it. There it is. Right? Earlier it was displaying somewhere here. Right? Now it is displaying here 200, 200. So this is how a simple applet will be executed. This is how you can execute a applet program. So now let us go further into this applet, complete this applet, and frequently we'll be using this applet along with AWT also come together. So you don't have a main method here. Now that you understood how the applets are created and compiled and executed, so let us go into types of applets. So there are two varieties of applets. The first one is that is directly based on applet class. So these applets use the abstract window toolkit to provide the GUI window. And the second type of applets are those based on Swing class. So Swing is another advanced concept in Java. Uh, this it is in the next level after AWT. So just like AWT, which will help us in creating window-based application programs using Java, Swing is another advanced concept, which is furthermore rich in features when compared with AWT. So there in Swing class, you'll also find all the classes that you are finding in AWT, uh, which are modified to beginning with J. Say for example, if there is an applet class that we are using now with AWT along with AWT, Swing will provide you with JApp. Okay? So if you have a button class here in AWT, then in Swings you have J button. So in that way, you have two versions of all these classes. One version is part of AWT, and the other one is part of Swings. Right? Swings is another advanced concept in Java. So applets can be created either using AWT's applet class or swing-based JApplet class. Okay. So what swing applets uses the swing classes to provide the GUI. Just like AWT provides us with some predefined classes using which we can create applets and display some content on the applet window. Even swing applets also use the swing classes that are provided by the GUI uh, by a package called Java X dot swing. Java
Sir,
X means
hello.
extend view. They are
Sir,
hello.
sir, what are the swing classes, sir?
First
Hello.
AWT classes should do.
Okay, sir.
First let us see AWT classes. AWT classes అయిన తర్వాత అదే క్లాస్ నేమ్స్
Okay,
స్వింగ్
sir.
క్లాసెస్ కూడా ఉంటాయి. అడిషనల్ గా J తో బిగిన్ అవుతాయి. అంటే చేంజ్ ఉంటుంది. అండ్ ప్యాకేజ్ వేరే ఉంటుంది. AWT ప్యాకేజ్ బదులు స్వింగ్ ప్యాకేజ్ అని ఉంటుంది. జావా ఎక్స్ డాట్ స్వింగ్ అనే ప్యాకేజ్ ఉంటుంది. ఆ ప్యాకేజ్ యూజ్ చేసుకోవాలి. సో yesterday we were discussing about API, right? Both these packages, Applet package and AWT package, will provide with all the predefined set of classes using we can create the graphical user interface and its components. In the same way, Swing package is there. That package will provide you with the predefined set of classes for creating Swing-based graphical user interface. Okay. So Swings, what is the difference between AWT and Swing means? Swing will offer a richer and often easier to use interface than AWT. Swing based applets are now the most popular than compared with the normal applets that are provided by AWT. So, however, traditional AWT based applets are still used, especially when only a very simple user interface is required. Thus, both AWT and Swing based applets are valid. Valid in the sense they can be used now, irrespective of whether people are using it or not, they can be used. Because a JApplet inherits Applet, all the features of Applet are also available in JApplet, right? So even though you go with the Swings concept, the JApplet class that is provided by Swing package, it is a subclass of Applet class, right? So coming to our regular AWT based Applet class, Applet provides all necessary support for Applet execution, such as starting and stopping. It also provides methods that load and display images and methods that load and play audio clips. So what you can do with Applet is you can display an Applet window and you can draw some text message on the Applet window. You can display audio clip. You can display some images in that Applet window using some predefined methods that are part of this Applet class, right? So for that purpose, this Applet class will be providing some methods. But before seeing that, we'll see what are the different classes provided for us, which will be helpful for us in creating basic applet window. So the applet class it extends AWT class called panel. That means what? AWT package provides you with a predefined class called panel, and for this panel class, applet class that is part of applet package is a subclass. And in turn, panel extends container, which extends component. That means what? At the top, you have component class, and component class has a subclass called container, and container class has subclass called panel, and panel subclass is applet. So at the top of the hierarchy, what you'll find is component, and component has a subclass container. Container has subclass panel, and panel subclass is applet. So coming to the nature of the applets, how they basically applets are event driven. Event driven in the sense they are not executed based on commands or something. Event means whenever a user performs some action on the graphical user interface, we call that action as a event. So whenever an event occurs, as a response to that event, applet will be executing some set of methods in it, then displaying the output on the screen. But generally, how the console-based programs work, they are not event-based, right? So we need to type some command and give some input to them, then they'll respond to our program, right? So basically, applets are event-driven. An applet resembles a set of interrupt service routines. I hope you remember the concept of service routines or interrupt service routines operating system. So when the processor is performing some activity, it will be interrupted with some important work. Then the processor holds that work it is doing and addresses this problem and then returns back to its normal mode. So this is called as interruption. Interruption for what? For a valid purpose. And when the processor gets interrupted, whatever task that is being performed, that is called as service routine. And totally we call it as interrupt service routines. Right? Some set of methods will be executed. So in the same way, Applet also will do the same work. It will be simply available displaying something on the screen. And whenever you perform an event or something on the Applet window, it will consider it and it will respond to that. It will provide a service to that action, and then return back to its normal position. So here is how the process works. An applet waits until an event occurs. The runtime system notifies the applet about an event by calling an event handler that has been provided by the applet. Once this happens, the applet must take appropriate action and then quickly return. So this is what I told you when I was discussing about the interrupt service routine, right? So initially, applet will be simply sitting idle, waiting for an event to occur. And whenever an event occurs, the applet will be notified about that event that it has occurred. Then the applet responds to that event and takes an appropriate action, and then it will quickly return back to its idle position. So this is how an applet works. So this is a crucial point. For the most part, your applet should not enter a mode of operation in which it maintains control for an extended period. Instead, it must perform specific actions in response to events and then return control to the runtime system. So what do you understand from this? Your applet will not be entering into mode of operation. Mode of operation means responding to the event. Most of the time, it will not be entering into the mode of the operation. So, and when it enters into the mode of operation, it maintains control for an extended period. Means the control will be switching between the Java runtime system and your applet program. So initially, the applet program will be idle until the Java runtime system notifies it about an event that has occurred. Once it is notified, then it will enter into the mode of operation and it will take the control of the system and then display, perform the task that is required for that event, and then give back control to the runtime system. Okay, so in those situations in which your applet needs to perform a repetitive task on its own, for example, displaying a scrolling message across its window, you must start an additional thread of execution. So that means what? In normal scenario, applet will take the control from the Java runtime system for a very short period and performs its task and returns the control to the Java runtime system. But if your applet has to do some work which is continuous, that means it has to repeatedly do the same task again and again for some period. Then in that case, what we need to create a separate thread of execution so that that thread will be performing this activity. Okay, so I'll show that also with an example program how to use a thread and display a scrolling message on an applet window. Itself, I'll show you. Second, the user initiates interaction with an applet, not the other way around. Means what? Interaction with the applet program will be initiated by the user first and not the applet first. Okay. So as you know, in a non-windowed program means the programs that we have seen till now before starting applet program, right? So as you know, in a non-windowed program, when the program needs input, it will prompt the user and then call some input method such as read line or something. Read line means to read some string of text from the command prompt, right? But that is not the case how an applet works. Instead, the user himself will start interacting with the applet as he or she wants when he or she wants. In case of console-based programs, the program will be initiating the interaction. But in case of applet, the user will be initiating the interaction. So these interactions are sent to the applet as events to which the applet will respond. So interaction is done in the form of an event. Event means instead of giving a command from the command prompt in console-based application, we'll perform an action. Action means by clicking on it or something, dragging it or selecting it something. So that is an event. And whenever you do that, you perform that event, the applet will respond with some different output on the screen. So, for example, when the user clicks the mouse inside the applet's window, a mouse clicked event is generated. Right? So when he releases the mouse button, then a mouse released event will be generated. So in that way, each and every action that you perform, that the user can perform, will be having some event name, and the applet will be notified with that particular event. And there will be some set of predefined methods which are available for each and every type of action that is performed with the user on the applet window, and automatically that methods get executed whenever the user performs that uh, event, right? So we'll see that with an example program of handling mouse events and keyboard events. But before going into that event mouse handling events and all, we need to know about another concept called event handling, because these applets are even based on event handling concept. So there is a model called of handling these events by the applets. So it is called as a delegation event model. So which is supported by the Java. We'll see first delegation event model concept how it works, and then we'll get back to this applet, uh, which will handle these mouse events and keyboard events. So we'll see those programs. The user presses a key while the applets window has input focus. A key press will be generated. So we'll look at each and every type of event that you can perform on applets later. So coming to this applet skeleton in the sense, whenever an applet window is created, this applet window will take the help of 5 different methods called, which are also called as life cycle methods. They're also called as life cycle. Okay. So the first one is the paint method, which we have seen in our applet example program just before. And along with that paint method, you also have 4 other methods, as I mentioned at the beginning: init, start, stop, and destroy. So what is the purpose of these 4 methods means their name itself will specify what is the purpose of this method. Init method, as its name indicate, it is used to initialize the applet. Then start method is used to start the applet. Stop method is used to stop the applet, and destroy method is used to destroy applet. Right? See how this sequence of these methods will be called during the entire life cycle like an applet. What do you mean by life cycle means? The moment the applet is created on your computer system, first it gets initialized, then it gets started. So whenever you start the applet, it will display a window. It will start displaying a window on the screen. Right? Then once the window is displayed on the screen, applet window, we say the applet has been started. We'll not be able to notice the initialization of applet because it is invisible to us, but we'll be able to notice the starting of an applet. How will you notice that starting an applet has started means you'll get that applet window displayed on your screen, a small window with whatever width and height you specified. So with that height and width, your applet window will get displayed on your computer screen. So then you can understand that the applet has been started, right? Then after started, after starting the applet, what will be done means immediately whatever you have defined in the paint method, the code written in the paint method, the paint method gets executed, and whatever code you write in the paint method, that thing, that output will be displayed in the applet window, right? So in our example program, what we have done in the paint method is we have simply drawn a string at a particular location called 20 comma 20 coordinates, right? So soon after the applet has been started, the paint method is executed and it will perform the action, whatever it is, whether displaying a string or drawing an image or playing an audio clip or something, whatever it is. And then after that, you can call the stop method. Stop method will be called by minimizing the applet window. So you have the minimization icons at the top right corner of an applet window as shown earlier, right? So if you simply click on that minimize icon, your applet will be minimized to the status bar of your computer screen, right? Then we say the applet has been stopped, right? Then again, when you open on that, when you click on the maximize icon and open it, again it gets started, and the paint method repaints the same code again on the screen. And finally, when you close that applet window by clicking on the into mark on the top right corner, the applet gets destroyed. So this is how these 5 different methods get executed one after the other. First, init method gets executed. Soon after you run your applet program by using that applet viewer, the first method that will be called is init method. Okay, and then the start method will be called, and then paint method, and after paint method, stop method will be called, and after stop method, destroy method will be called. Init method and destroy method will be both called only once in the life cycle of the applet. Okay, so these methods apply to all applets and are defined by applet class. So which class defines the applet? These methods means applet class contains these 4 methods. Paint method is not defined by the applet class. Okay, paint method is not defined by the applet class. It is only these 4 methods are defined by this applet class. Paint method is defined in another class called component class. So just before in the previous slides, I told you there is a predefined class at the top. For applet, you have panel. Panel has a container, and then it has another superclass called component class. So applet is a subclass for all these classes. So that super class called component class, it has the paint method. So we are redefining this paint method in our applet class once again. That means we are overriding that paint. So except this paint method, remaining 4 methods of the life cycle of an applet are directly members of applet class. They are defined inside the applet class. So default implementations for all these methods are provided. Applets do not need to override those methods. They do not use. So for all these 4 methods, default implementations are provided by the applet class. Because you are creating a class and making it subclass for applet, automatically these 4 methods definitions will also be part of your applet class. So they automatically get executed. Once you run your applet program, automatically init method gets executed, and then start method, then paint method, then stop method, and destroy method. Okay, all these methods will be called based on whatever action you perform, whether you minimize the applet window, maximize the applet window, close the applet window, whatever action you perform. Based on that, that method gets executed. But init method will be executed without the event performed by the user, because when you run the program initially, first method that will be executed will be init method. So this will initiate the applet program. So once this init method is executed, then the start method will be called automatically, and then stop method will be called by minimizing the window. And again, when you maximize the window, again start method will be called, and paint method will be called automatically. And destroy method will be called when you close the window. Okay. So only when you are using simple applets, we need not define all of these methods except the paint method. We can skip all the other four methods. AWT based applets will also often override the paint method, which is defined by AWT component class. So this paint method can also be overridden. Okay. So that is what we have done in our program. We have created our own definition for the paint method instead of using the default version of the paint. So this method is called when the applet's output must be redisplayed. Each time you want to change the content of an applet, this paint method will be called again and again. These five methods can be assembled to form the skeleton of an applet. So what do you mean by skeleton of an applet means? Your applet contains all these five methods. So they'll form the skeleton of the applet, or we can also call them as life cycle of an applet. The methods are called as life cycle methods. So applet initialization and termination. It is important to understand the order in which these various methods shown in the skeleton are called. So already I explained you all these things, right? First, which one will be called init method, then the start method, then the paint method, and then stop and destroy. Right? So when an applet begins, the following methods are called in the sequence. When an applet begins means what? When you run your applet program, automatically in this sequence, these three methods are called. First init method is called, then start method is called, and then paint method is called. And when the applet is terminated, when you click on the icon, into mark on the top right corner, stop method will be called first automatically, and destroy method will be called later. But the stop method can also be called when you maximize and when you minimize the window. Okay, and even this init method, start method also can be called when you maximize. So the init method is the first method to be called. This is where you should initialize variables. This method is called only once during the runtime of your applet. So how many times this init method will be called? Only once during the entire life cycle of an applet. The start method is called after init. It is also called to restart an applet after it has been stopped. Means what? When do you stop an applet? By minimizing it, you'll stop it. Again, when you maximize that window, which method will be called? Start method will be called. Init method will not be called again. Init method will be called only the first time when you run the app. Then after the applet window is displayed, you minimize it and maximize it. When you minimize it, stop method will be called, and when you maximize it, start method will be called. Okay? So init method is only called once. The first time an applet is loaded, and start is called each time an applet is displayed is on the screen. Displayed on the screen means it may be for the first time it is being displayed on the screen, or later when you minimize the applet window, again you may maximize it and display it on the screen. Right? So in that way, each time you maximize your applet window from the status bar, the task bar, the start method gets executed. And each time you minimize the window to the taskbar, the stop method gets executed. And once the start method is called, even paint method also will be called again and again. So init method, start method, paint method, and stop method, all these three methods will be executed multiple times during the entire life cycle of now. But coming to init method will be called only once in its lifetime. Okay. So if a user leaves an applet and comes back the applet resumes execution at start. Leaves an applet means what? By minimizing the applet window, we are leaving that applet and we are switching to another program, right? So that is the meaning of leaving an applet. And once you come back to this window, that means you maximize that applet window again, then immediately start method again resumes. So the paint method is called each time in AWT based applets output must be redrawn. So each time you maximize your window and again the same content that was displayed earlier must be displayed again now. It must be visible to the user. So the paint method will be again called. So in that way, paint method will be called multiple times. This situation can occur for several reasons. For example, the window in which the applet is running may be overwritten by another window and then uncovered, or the applet window may be minimized and then restored. Paint is also called when the applet begins execution. In that way, for different reasons, the paint method will be called. You may minimize it and maximize it, or you may run another applet program which has occupied this applet window. So, for several reasons, the paint method will be called. Whatever may be the cause, whenever the applet must be redrawn, its output, the paint is called. And the paint method has one parameter of type graphics class. We have already seen. This parameter will contain the graphics context, which describes the graphics environment in which the applet is running. This context is used whenever the output to the applet is required. So that means to draw anything on the applet window, we have to use this graphics context. Graphics context is nothing but the graphics class object that we have passed as parameter to this paint method. And that class contains several methods to perform all the graphical activity, drawing something on the screen. So to whatever operation you want to perform, for that there will be a predefined method. You need to call that predefined method. In our example, we have called the drawString method using the graphics object. And the stop method is called whenever a user leaves the applet. Leaves the applet may be for many reasons. It may be you're destroying the applet by clicking on the closed window of the applet, or you have minimized the window also. So when stop is called, the applet is probably running. You should use stop to suspend threads that don't need to run when the applet is not visible. You can restart them when start is called. The user returns to the page. In that way, when you switch the window to a different window, say now, for example, I'm using this PPT window. If I click on Alt Tab, I will be switching to different windows. Right? In the same way, one of the window may be an applet window. So if I switch away from this applet window to some other window, then automatically what will happen? The stop method will be called. Right? And whenever I switch back to that applet window again, then again the start method will be called. In that way, whatever may be the reason for you to switch back, either by minimizing it or the window will remain as it is, but you will be moving to a different window instead of uh, using the screen to watch this window. You are using the same screen to watch something else. Now, currently, I'm watching this PPT slide. I want to watch something else. Say, I want to watch this command prompt. So I'll switch to this window. So now, what is happening to that PowerPoint slide? It has been stopped. So, for example, if that is an applet window, then we say that the applet has been stopped. Again, if I switch back to that window, now what will happen? The applet will be started. That means start method will be called. Okay. And the other reason is you may minimize this window. Okay. You will be minimize it like this by clicking on it. And again, you may want to maximize it by clicking on this one. So when you minimize also, stop method will be called. And when you maximize it, start method will be called. And the destroy method is called when the environment determines that your applet needs to be removed completely from memory. Means what? You don't want to use that applet window again. You'll click on that cross mark on the top right corner, right? So then this destroy method will be called. But when you click on that cross button, first stop method will be called, and then destroy method will be called. Directly destroy method will not be called. Right? First stop method will be called and then destroy method will be called. So that is what mentioned in the last point. The stop method is always called before destroy method. And before destroying, all the resources that the applet is using, they will be released. They will be released, and then the applet will be stopped, and the destroy method will be called. Okay, so this is how applets will work. So tomorrow I'll show you one more example program, a simple banner applet program with the rest of the topics. Okay.
Okay, sir.